Good day, everyone. Today, we will talk about the greenhouse effect and ozone depletion. Greenhouse effect is an extremely vital process where infrared rays from the sun come into the Earth's atmosphere. The atmosphere then traps these rays after they have come in, keeping the Earth warm and habitable. CO2 or carbon dioxide, N2O or nitrous oxide, and CH4 or methane are destroying the atmosphere, causing more infrared rays to reflect on Earth. Having more infrared rays reflected on Earth makes the Earth warmer. As the temperature on Earth rises, so does the ocean water level and the ice caps begin to melt. The worst possible scenario with the problem would be mass flooding in low-lying areas of Earth, including many islands in the ocean, which would basically disappear. Most of Florida would be underwater. All coastline cities and river deltas, such as Bangladesh, Pakistan, China, Egypt, Louisiana, and other parts of US. It will also cause more tropical storms, hurricanes, extreme temperature, and droughts. So what causes a greenhouse effect? The main cause of the greenhouse effect are gases called carbon dioxide, nitrous oxide, and methane. Small amount of carbon dioxide in the air helps keep heat in Earth in the vital process of the greenhouse effect. A car exhaust and industries cause a shoot of CO2 in the air. The amount of CO2 will increase. This causes more heat to be kept, increasing the Earth's temperature. Methane and nitrous oxide that has the same effect as CO2, but they have a less harmful effect on the greenhouse effects. So here is a little demonstration about the greenhouse effect. Solutions: reduce usage of greenhouse gas emissions, which emits carbon dioxide, methane, and nitrous oxide. Prevent forest fires and depletion of trees. Do not use nitrogen-based fertilizer to reduce the amount of nitrous oxide. So now we will talk about the acid rain. Acid rain is a broad term used to describe several ways that acid falls out of the atmosphere. A more precise term in acid deposition, which has two parts, wet and dry. Wet deposition refers to acidic rain, fog, and snow. As this acidic water flows over and through the ground, it affects a variety of plants and animals. The strength of the effect depends on many factors, including how acidic the water is, the chemistry and the buffering capacity of the soils involved, and the types of fish, trees, and other living things that rely on the water. Dry deposition refers to acidic gases and particles. About half of the acidity in the atmosphere falls back to Earth through dry deposition. The wind blows these acidic particles and gases onto buildings, cars, homes, and trees. Dry deposited gases and particles can also be washed from trees and other surfaces by rainstorms. When that happens, the runoff water adds those acid to the acid rain, making the combination more acidic than the falling rain alone. Prevailing winds blow the compounds that causes both wet and dry acid deposition across state and national borders, and sometimes over hundreds of miles. Scientists discovered and have confirmed that sulfur dioxide and nitrogen oxides are the primary cause of acid rain. Acid rain occurs when these gases react in the atmosphere with water, oxygen, and other chemicals to form various acidic compounds. Sunlight increases the rate of the most of these reactions result in a mild solution of sulfuric acid and nitric acid. Measurement of acid rain is measured using a scale called the pH. The lower the substance pH, the more acidic it is. Pure water has a pH of 7.0. Normal rain is slightly acidic because carbon dioxide dissolves into it, so it has a pH of about 5.5. As of the year 2000, the most acidic rain falling in the US has a pH of about 4.3. So, what is a pH? Acidic and basic are two extremes that describe chemicals, just like hot and cold are two extremes that describe temperature. Mixing acids and bases can cancel out their extreme effects, much like mixing hot and cold water can even out the water temperature. A substance that is neither acidic nor basic is neutral. The pH scale measures how acidic or basic a substance is. It ranges from 0 to 14. A pH of 7 is neutral. A pH less than 7 is acidic, and a pH greater than 7 is basic. Each whole pH value below 7 is 10 times more acidic than the next higher value. For example, a pH of 4 is 10 times more acidic than a pH of 5 and 100 times more acidic than a pH of 6. The same holds true for pH values above 7, each of which is 10 times more alkaline. Another way to say basic than the next lower value. For example, a pH of 10 is 10 times more alkaline than a pH of 9. Pure water is neutral with a pH of 7.0 when chemicals are mixed with the water. The mixture can become neither acidic or basic. Vinegar and lemon juice are acidic substances, while laundry detergents and ammonia are basic chemicals that are very basic or very acidic are called reactive. These chemicals can cause severe burns. Automobile battery acid is an acidic chemical that is reactive. Automobile batteries contain a strong form of some and the same acid in the acid rain. Household drain cleaners often contain lye, a very alkaline chemical that is reactive. Here is an example of a pH scale. So as you can see, when a substance is on the neutral, it means it's 7 to 0. That is what we call the acidic. And when it is on 7 up, it will be alkaline or non-acidic. So on number 6, we have urine and milk. On number 5, we have the black coffee and bananas. Number 4, we have the tomato juice and acid rain. On number 3, orange juice and soda. Number 2, lemon juice and vinegar. And number 1 is the concentrated sulfuric acid. And on the last, which has the highest acidic content, is the battery acid. So pure water is neutral, that is on 7. So we have seawater and eggs on number 8, baking soda on number 9, milk and magnesia, Great Salt Lake are on number 10, ammonia solution on number 11, soapy water on 12, bleach or oven cleaner in number 13, and we have liquid drain cleaner on number 14, which has less acid. So we will move on to the effects of acid deposition. Acid deposition has a variety of effects, including damage to forests and soils, fish, and other living things, materials, and human health. Acid rain also reduces how far and how clearly we can see through the air, an effect called visibility reduction. The acid rain effects section provides more details on each of these. So solutions. There are several ways to reduce the acid deposition, more properly called acid deposition, ranging from societal changes to individual action. Number one, we should clean up smoke stacks and exhaust pipes. Use alternative energy sources such as solar energy or wind energy. Restore a damaged environment, just like replanting trees when we cut down one. Individuals can contribute directly by conserving energy since energy production causes the largest portion of the acid deposition problem. For example, you can turn off lights, computers, and other appliances when you're not using them. Use energy efficient appliances, lighting, air condition, air conditioners, heaters, refrigerators, washing machines, and etc. So we will move on to the ozone layer depletion. Ozone layer depletion. The ozone layer is a gaseous cover in the Earth's atmosphere that serves as a shield against dangerous ultraviolet radiations. Excessive level of UV radiation can cause cataracts, skin cancer, and immune system suppression in humans as well as having harmful effects on other living systems. Chlorofluorocarbons or CFCs prevents in styrofoam, refrigerants such as in air conditioners, and cleaning agents such as ammonia are largely to blame for the degradation of the ozone layer. Toxic emissions and burning of fossil fuels by power plants, factories, and other engines also play a role in the alteration of ozone layer functioning. So here is a concept of ozone layer depletion. We have the sun sending UVA and UVA towards the ozone layer. The ozone layer contains CFC molecule which has chlorine, fluorine, and carbon. The ozone molecule that has 3 oxygen molecules. Ultraviolet rays split a chlorine atom away from a CFC. The chlorine atom breaks up an ozone molecule, making a hole in the ozone layer. The molecule left behind are chlorine monoxide and oxygen. So ozone depleting chemicals, CFCs, example of these are aerosols, refrigerants, and solvents. We have HCFCs. They came from aerosols, refrigerants, and solvents. We have halons from fire extinguishers and methyl bromide from pesticides. So how to avoid this ozone layer depletion? Avoid using styrofoam whenever possible. Replaceable styrofoam cups with a mug. Buy individual fruits and vegetables rather than those packaged in styrofoam containers. When shipping fragile goods, wrap them in newspaper or use plastic bubble wrap instead of styrofoam. Avoid using a car when it's not crucial. Take public transportation, ride a bicycle or walk. If when driving is necessary, carpool with others. Use a fuel-efficient vehicle and super unleaded gasoline. Avoid using excessive power. Turn off the lights, TV, stereo, computer, and other appliances when you leave the room and especially when you leave your residence. Want to keep a light on while you're away at night to discourage burglars. Use a timer to control when your light switch on and off. Install energy efficient bulbs such as halogen lamps. Wait until the dishwasher is full before running it. Use a screensaver for your computer. At work, at your apartment, take the stairs instead of the elevator when you can. So that's the end. Thank you for listening.